So today we discuss about the properties of infinite series. The properties of infinite series. So first property is the nature of an infinite series does not change. The nature of an infinite series does not change. What does it mean? It actually means by the multiplication of all the terms by constant, so does not change. By what? 1 by multiplication of all the terms with constant k. And the second one is by addition or the deletion of the finite number of terms. By addition or deletion of a finite number of terms. And the second property is if two infinite series, if two infinite series let's the infinite series is un and vn, okay, are are convergent, then the summation of un plus vn also convergent, also convergent. This is the property 2 of an infinite series. So let's talk about the properties of a geometric series. Properties of a geometric series. Of a geometric series. So a series, let's take a series. This series 1. The first term is 1. Then second term is r plus r square plus r cube plus dot 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 is infinite. Okay, is first is convergent. So what is the condition of convergent? The convergent if modulus of r less than equal 1, and second is divergent divergent if r greater than equal to 1, an oscillatory. So here we have to notice that it is modulus of r. So what is mean by modulus of r less than 1? So let's see later. Okay, so oscillatory. Oscillatory means that it oscillate between two values. Okay, oscillatory if r less than equal to minus 1. Okay, so let's plot it in a number line so it will be easy to visualize. So this is our number line. Okay, so here it is a 0, it is -1, it is -1, and it is plus. Okay, so what is actually says this is -1 to +1. So in this range it will convergent, it convergent. Okay, so what actually means the value of r will lie between -1 to +1. So this sign is mean that we should not take the value of -1 and +1, exclude the point -1 and +1. Okay, so divergent if r greater than equal to 1. Okay, so if the value r is greater than equal to 1, then it will diverge. Okay, so if the value less than -1, so it oscillate, it oscillate. Okay, so this graph is important to visualize, and to know whether any point is left or not. So we can clearly say that there is no point left. We take -1, we take the point, all the points less than -1, we take the points from all the value -1 to 1, and also take the value greater than equal 1. So let's prove. Okay, so what is the proof? First is convergent if r less than 1. So when r less than 1. So what is the summation? Okay, so what is the summation? Limit n tends to infinity, n tends to infinity. Okay, n tends to infinity Sn. So what is the formula of Sn? Limit n tends to infinity. So what is the formula of the summation of a geometric series? As r less than 1, so the formula will be 1 r to the power n by, as it is less than 1. Okay, so 1 minus r. So we have to find the value of r to the power n when n tends to infinity and r less than 1. So let's find the value. Limit n tends to infinity, r to the power n, as it is less than 1, so it obviously 0. So here limit n, sorry, so here the value will be 1 minus 0 by 1 minus r. So this will be our 1 by 1 minus r. So hence the series is convergent. Hence the series convergent. Okay. Now second case, that when r is greater than 1, when r greater than 1. Okay. So the formula of Sn is equal to r to the power n minus 1 by r minus 1. Okay, we know that. So here we have to find the value of r to the power n when n tends to infinity. So limit n tends to infinity Sn. When n tends to infinity, then what is the value of Sn is equal to, we also take the limit n tends to infinity r to the power n minus 1 by r minus 1. So as r greater than 1, so it is obvious that limit n tends to infinity r to the power n also infinity, so this terms also tends to infinity. So when n tends to infinity, the summation of this series, summation of the geometric, sorry, then the geometric series also tends to infinity. Hence the series is divergent. Okay. And there is a second case, because we should not leave any point, because we also take the point 1. Okay. So when r is equal to 1, what will happen? Let's see. When r is equal to 1, then the value 1 1 1, because we know that 1 square is equal to 1, 1 to the power q is equal to 1. So power, any power will give the point value 1. So this series will becomes will become 1 plus 1 plus 1 plus, it's on to infinity. So Sn is equal to infinity. So here also the series is divergent. Series is divergent. Okay. Now we take that when r less than 1. Okay. When r, and third case, when r less than equal to minus 1. Okay. So first we take the value when r is equal to minus 1. When r is equal to minus 1, what will happen? The series will be, let's write the series again. That is 1 plus r square plus r cube plus dot 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 infinity. Okay. So the series will be 1 plus minus 1 plus minus 1 to the square plus minus 1 to the power cube. Okay. So this will 1 minus 1 plus 1 minus 1 plus 1, and this will continue. So if we consider that, if we take the value 1 first term, then it will 1. If take 2 value, then it will 0. 3 value, then it will 1. So Sn is equal to 0 when we take an even term. So if we take two terms 0, if we take four terms 0, so if n is even and Sn is equal to 1, okay, is equal to 1 when n is odd. If n is odd, so if we take 1, then it will 1. If we take 3, n is equal to 3, then it will also put the value, also give the outcome of value n 1. So hence the series oscillated, it oscillated between 0 to 1. Let's see when r less than minus 1. So let r is equal to minus k, where k is equal to 1. Okay, so this r to the power n is equal to minus k to the power n. So minus k to the power n is equal to minus 1 into k n. So minus 1 to the power n into k to the power n. So the limit n tends to infinity Sn. What is the value? So limit, we can see that if r is equal to minus k and k is equal to plus 1, then we can say that this will the same as the first one. Okay, this is the same as first one, as k is less than 1. Okay, so limit n tends to infinity 1 minus r to the power n by 1 minus r. So if we put the value that r is equal to minus k, then it will become n tends to infinity 1 minus 1 to the power n k to the power n 1 minus k. So it will plus infinity if n is odd, and it is minus infinity if n is even. Okay, so hence this series is also oscillated, hence it also oscillated. True. Okay.